Hi everybody, I'm Son. Today I'm happy to be here to share my dissertation on the topic of research about semi-automation solution that generate the BIM model from the point cloud data. In 4 months of my dissertation, I work under the main supervisor of Dr. Elder Souza and Mr. David Reister and Jure Seknik from my company LAIC. So Um, I want to start with my idea and motivation. This is figure out a new method to decrease time consumption to create the BIM model from point cloud data in the common project types. However, the new process should be easy to apply on large scale and easy to apply in our achievement. Our solution decrease at least 50 total time spent for creating the BIM model from the point cloud data, and the BIM model in every level can apply it fluently less than one working week. So this is the slide. So my research roadmap in terms of the literature review, I focus on capturing the current process of scan to BIM into typical project types as the common building and the historical building. In terms of the methodology, I identified the important step to prepare for the data collection process. After that, I compare the time consumption and the model quality between the traditional uh, process and semi-automation process. So this is short definition of the scan to BIM process. This is the process to collecting and recreating the as-built BIM model of the construction project model via point cloud data. So for the application of scan to BIM, they have a variety of application in design phase, like survey existing land in the construction phase, or in operation and maintenance phase, or even the asset management. So this is a methodology of applying scan to BIM in the common project were proposed with a sequence step, as you can see, and it proved with example that is scan to BIM to analyze it and renovation project. From this method, I realized that the most important factor uh, decided to the success of scan to BIM process is identify the classification of element, what should be captured and rebuilt in the BIM model, and the LOD of each element. In the construction side, it is the scan the design and the software we use to create the BIM model and analyze it. So continue with the methodology of scan to BIM to heritage building. This type of project like have almost necessary step is similar, but the LOD of all element is higher and the geometric data of the historical building will be much more complicated. And the last part of literature review, I show here some popular algorithm to use to create the BIM model based on point cloud data. It will be segmentation, refinement, and boundary mapping, and then object recognition. So in the methodology part, I started with the data collection process and how to get the high-get point cloud quality. Firstly, the scan station should be well organized to make sure it can capture every object with a minimum number of devices and the high-get overlap area. The second one is requirement for special object. For example, the door and the window should be open to capture high-get accuracy dimension of the opening, and the mirrors or reflection object should be removed to reduce the time spent on delete the noise object. In this slide, we can see the advantage of have overlap area. From this, we can easily measure point cloud data with high accuracy. And the last part, the last two picture is remove the incorrect data. For example, it is the reflection point from the mirror. So the last part of methodology is defining the main goal and the LOD requirement for the model will be built. In the first case study, we used a terrestrial laser scanner from Leica, and as can be seen here, this is current situation of the building with the quality of point cloud data is not good and have many noise or missing objects in some parts. For example, the roof and the floor. In this case study, we aim to test the ability of the semi-automation process, so we didn't expect the high LOD of the BIM model. On the other hand, we expect to save at much time. That's why I set the LOD of every element around 100 to 2000. It's enough to have a good geometric information. So in this is a working process of two case study of the case study. In the first step is cleaning the point cloud data, and it means delete or remove unnecessary or noisy point. In traditional process, the BIM model have to go inside the file by recapture and delete object manually by hand, but with the new process, the task will be easy because it's only take 15 minutes to do because all of the automation by the software. In step 2 is define the location of project is, and in step 3, normally create the level. To create the level, I have to create many sections to estimate the elevation of the floor and put the elevation after that. It took around 40 minutes for the task, but with the semi-automation process, they already classification floor and set up the level after that. So I take only 3 minutes. As you can see here in step 4, 5, or even 6, every object like wall or door will be automatic classification and create. So the BIM model only need to edit or adjust the object to get more accuracy or to improve the detail of the object. So in this slide, I show in details the process of creating the roof and the timber. So as we can see here, a lot of objects missing data and we cannot create it by hand, but however, with the suggestion from the software and we can create easily, but in 15 minutes, in the second case study, I aim to check the software, the ability of software to the drawing the pie in a specific area. So I set the LOD for pie segment is 2000 with high accuracy about diameter, length, and the slope. So I will focus on step 3 and 4 in this case study because the previous steps are similar. With the first case study, we know that drawing by segment normally require at least 3 section view to refer its main parameter, including diameter, length, and slope. But even if we have enough the section view, the BIM modeler can only create the pie segment when it located in good point cloud quality. On the other hand, working with the semi-automation process, the task is totally easy. I only need to decide the diameter of the pie and draw in it based on the suggestion of the software, because the software remove every noisy object and then present only pie, so it will be easy to recognize by eye. In the second case study, with this case study, but the second solution, I use XY software. It works with entire data instead of working with only one pie segment, and it will extract the pie based on its boundary, and after extract all pie, it will give us the notification that the pie can have a mistake. So I will decide to delete or to assert before export to Revit. After all process, the file exported to Revit, they have a high accuracy and very promising for application in large scale. In terms of interoperability, I test it by exporting directly from Revit to IFC format. As you can see here, all the property set and the 3D geometric information are present fluently. They don't have any missing object or crash in the data. So for my future, in conclusion, the solution demonstrates its ability in the two real projects over two case study. And now for the future direction, I want to research more about its opportunity in infrastructure project and railway system. In other hand, maybe trying to apply the automation solution to create the SBV model of the complex industrial project or an historical building which have many decoration and high detail. So this is my presentation. I would like to say thank you with all of you guys.